Howdy. This is the same exact problem we just looked at. It's another system of linear equations, and we're going to solve it a little differently. We're going to solve it using addition and subtraction, but first I'll show you a quick tip for this problem. I want you to notice that everything in the problem, the decimal, comes out to the 10th place for each of these terms, okay? And since that's the case, what if we could just what if we could get rid of all of the decimal points throughout this entire problem? That would save us time and energy. We would have to write them, and thinking about it, we would be able to think about the equations a little more easy. So what I'm going to do is I'm going to multiply everything up here by 10, and I'm going to multiply everything on this side of the equation by 10 as well. Alright? And I really want you to think about this for a second. Whenever you're dealing with an equation, let's rewrite it. 1.2x minus 0.5y equals negative 5.8. Whenever you're dealing with an equation, whatever you do to one side, you do to the other. You can do anything you want to one side, and as long as you do the same thing to the other side. Alright, so if I multiply this side by 10, I multiply everything over here by 10, that will give us the following. Multiplying 10 by this decimal, it just equates to moving the decimal point over one place. This just becomes 12x minus 0.5y. Oh wait, 10 times 0.5 is actually just 5 equals, and 10 times negative 5.8 is negative 58. And now we've just transformed this difficult looking problem with decimals in it to a regular old-fashioned problem with integers. Okay. We can do the same exact thing for this top part here. So we just multiply everything up here by 10, everything over here by 10. We just get 3x plus 24y equals 36. That's the first tip on an easier way to solve this problem. The second thing I want to let you know about is the following. We can solve this, as I said, via addition and subtraction. What I mean by that is the following. I can add or subtract iterations of one of these things to the other. Okay? Let me show you exactly what I mean. 12x minus 3x would be 9x. So I can take this and subtract this. But that'll just give me 9x, and that's not really that exciting. Let's actually take it a step further. I know that we just went ahead and multiplied everything by 10. I'm going to take the bottom equation, I'm going to multiply everything by 4, and I hope that'll make sense in just a second as to why I'm doing this. But I'm going to multiply everything at the bottom of this equation by 4. So 4 times 3x is 12x. 4 times 24, and you can pull out your calculator for this, but 4 times 24 is 96y equals, and 36 times 4, well, that's 144. Bring down our addition sign, rewrite the top part, 12x minus 5y equals negative 58. Now, like I said, we can add and subtract iterations of the top one from the bottom one, or vice versa. Doesn't matter. We're going to actually, if we do this, end up with an answer. So let's just do this. Let's subtract these. Okay? 12x minus 12x is 0, and that's what we want. That's why I multiplied by 4 up here. I wanted to transform this 3x into a 12x, so that when I subtracted this, I got a 0 here. Next, negative 5 minus 96. That's negative 101y. And negative 58 minus 144, well, that's negative 202. Okay. Pause for a second. Take a look at what we got. Let's get rid of this, and let's solve for y. Divide both sides by negative 101. We get y is equal to, well, 202 divided by 101, they're both negative. We're going to end up with a positive 2. Y is equal to 2. That is the same conclusion that we came to when solving this via substitution. This method works. Alright, so y is equal to 2, so if we plug it in, y is equal to 2 for both of these equations. And I'm only going to do one, because I've shown you that if we substitute x in for both of these, we get an output of y already, right? I've already shown you what that should be. You can go back to the previous video, you can see what that is. After we substitute 2 in for y for either of these original equations, we're going to get the same output for x. Now, here's the deal. We can substitute it in to either of these up here. We can substitute it into either of these right here. We could substitute it in right here. Let's go back to the very base equation, okay? Just to prove to you that even though we modified it by multiplying everything by 10, it didn't change anything at all, okay? Let's go back to this primary first start here. So 1.2 times x minus 0.5 times y, which is 2, equals negative 5.8. All right? Negative 0.5 times 2 is just negative 1. 1.2x minus 1 equals negative 5.8. Add 1 to both sides. That'll give us 1.2x equals negative 4.8. Divide both sides by 1.2. We get x is equal to negative 4. All right? And that is how to solve using all the tools at your disposal. Really, you can we multiplied 2 different times, we subtracted, and we solved using substitution at the very end. All the methods at your disposal. Choose which one works better for you. All right. This seems to me a little more streamlined. I didn't have to deal with as many decimals, so things were a little easier. But we came to the same answer. The same answer being negative 4, comma, positive 2 as our ordered pair. Thank you.